Have you ever wondered how oil is extracted from a grain that feels completely dry to the touch? That simple golden bottle of oil sitting on the supermarket shelf actually comes from one of the most extreme and precise processes in modern industry. Imagine millions of hard-dried corn kernels being transformed into pure liquid by machines working so fast they seem to defy human vision. Every single second, tons of corn pour into metallic funnels that swallow everything as if they were starving, and this is just the entrance to one of the most impressive industrial chains in the world. The process of making corn oil involves violent temperatures, grinding as fine as dust, and a sequence of steps so sensitive that any mistake can turn entire loads into waste. If you're new here, welcome to a place where we open doors that almost nobody gets to see. Now, before we move to the next steps, and trust me, they read jaw-dropping, make sure you subscribe to the channel. Already subscribed? Great. Now, tell me, which other common food do you think goes through the most brutal process before reaching your table? Let me know in the comments. Right after this brutal initial selection of the grains comes a curious detail. If you watched our last episode about olive oil, you'll notice that corn oil follows a completely opposite path, where delicacy gives way to brute force and heavy engineering. It's almost like comparing artisan surgery to a colossal industrial operation. And this is exactly where the story begins. Sensors analyzing each grain in fractions of a second, machines separating impurities with clinical precision, and metallic giants moving tons as if they were feathers. All of this to ensure that only perfect corn enters this mechanical ritual that transforms the impossible into oil. The first impact when entering a corn oil factory is realizing the absurd scale of everything. Trucks dump mountains of corn into gigantic silos capable of feeding an entire city. Each grain passes through optical sensors that analyze color, brightness, and micro defects in fractions of a second. It's a relentless screening. Only corn with ideal moisture and starch levels moves forward. After selection comes washing and precise drying. Here, every detail matters. 1% more moisture already compromises extraction yield, affecting temperature, pressure, and press efficiency. It's like preparing an athlete. Nothing can be out of place. The next stage is milling, where corn is crushed until it becomes a dense flour. Rolling mills separate the husk, germ, and starch. And it's in the germ, the smallest part of the grain, where the real treasure lies. A fact that surprises many people. Out of 100 kilograms of corn, less than 5 kilograms have real potential to produce oil. The rest becomes flour, animal feed, and industrial derivatives. Nothing goes to waste. With the germ isolated, mechanical pressing begins. Imagine a steel screw compressing the material with so much force that the temperature rises immediately. The crude oil drips through the cracks, while the dry residue, called cake, moves on to another treatment. Even so, this powerful press extracts only about 60% of the total oil. There is still a lot hidden in the meal, and that is where the most sensitive step comes in: extraction by solvent. Hexane, the most common solvent, passes through the meal like fine rain that dissolves the remaining oil. The result is micella, which is the mixture of oil and solvent. In evaporators, hexane is removed and recovered with impressive efficiency. More than 99% returns to the system. The crude oil moves to heated tanks, dark and with a strong smell, awaiting purification. The solid residue goes through a desolvenization process, transforming into protein-rich animal feed. The chain is so efficient that some factories reuse excess heat to generate steam, keeping the process practically self-sustainable. But before we move forward, let me ask you something. Are you enjoying this dive into corn oil engineering? Then go ahead and leave your like right now. It really helps bring more industrial behind-the-scenes content to the channel. And you know what's incredible? Despite all this gigantic structure, oil represents less than 5% of the grain's total value. The process only exists because everything around it, meal, starch, feed, keeps the operation profitable. And now that you've seen how oil is born from brute force combined with chemical precision, we're going to enter the phase that will transform this dark, impure liquid into a clear, smooth, and edible product. And it's exactly in this next step that the real industrial alchemy begins. The crude oil that comes out of extraction is far from the golden liquid you see on the shelf. It arrives at the tanks with a dark color, intense smell, and full of microscopic particles that need to be removed with absolute precision. This is where the most sensitive and at the same time most elegant phase of the process begins. Each step works like a filter that polishes the oil until it becomes clear light and completely safe for consumption. The first major step is deguming. The oil is heated and mixed with treated water. This water reacts with phospholipids, forming a kind of thick gum that naturally separates from the oil. When this gum is removed, the liquid already begins to take on a more uniform appearance. The curious thing is that this gum, which many people imagine is discarded, is actually reused by the pharmaceutical and feed industry. Nothing is wasted, and that's exactly what makes this process so fascinating. Every byproduct finds a new path. After deguming comes neutralization, responsible for removing free fatty acids. These acids would leave the oil with an unpleasant taste and reduce its durability. To eliminate them, the oil is mixed with a mild alkaline solution, usually sodium hydroxide. This solution reacts with the acids, transforming them into soaps that settle to the bottom of the tanks. It's as if the oil goes through a chemical bath that returns its essential purity. Science makes something invisible to the eyes, but totally perceptible in the final aroma and flavor. The next step is bleaching, a process that involves special clays capable of capturing even smaller impurities. These clays work like microscopic magnets for pigments, metals, and organic residues that resisted previous phases. When the oil passes through large filters filled with this material, it emerges visibly clearer. It's an almost hypnotic moment for those who observe. The dark oil transforms into a yellowish, translucent liquid before your eyes. But even with all this evolution, one essential step is still missing: deodorization. The name may sound simple, but the process is surprising. The oil is heated to extremely high temperatures in vacuum chambers, which causes volatile compounds responsible for strong odors and flavors to evaporate completely. This combination of heat and absence of oxygen creates a perfect environment to eliminate everything that could compromise the smooth aroma of the final product. The result is a light neutral oil ready to be used in all kinds of cooking. At this point, it's worth pausing to think about the complexity of this transformation. We started with dry grains practically without an oily appearance and arrived at a delicate crystalline and stable liquid. It's a giant leap, and each phase depends on the previous one with almost surgical precision. Taking advantage of this moment, let me ask you, which stage of this purification did you find most impressive so far? Comment below and also tell us from which city or state you're watching from. Going back to the process, the last part of this act is final filtration, where the oil passes through ultrafine membranes that remove any residual trace of clay soaps, particles, or unwanted compounds. It is no exaggeration to say that this filtration works almost like an invisible sieve, separating perfect oil from any microscopic imperfection. When this step is complete, the oil is officially ready for the next phase: final refining and bottling. From here, ultra-fast machines will take control, filling, sealing, and labeling thousands of bottles per minute. This is the stage you're about to discover, and you'll all be surprised by the speed of these production lines. When the oil comes out of purification, it is already clean and edible, but still needs to go through the stage that guarantees stability, shine, and neutral flavor for months: final refining. This phase combines thermal precision, advanced filtrations, and strict quality controls. The oil is heated again, this time in an extremely controlled way to adjust its viscosity and remove any trace that could compromise durability. Sensors spread throughout the pipes monitor temperature, pressure, and flow in real time as if they were invisible guards, ensuring everything is perfect before moving forward. Next, the oil reaches the polishing lines, where it passes through microfilters capable of retaining particles so small that even conventional equipment could detect them. It's impressive to observe how enormous machines dedicate themselves to polishing such a light liquid. With each new filtration, the oil gains more transparency until it reaches that characteristic shine that consumers recognize on the shelf. It's one of the most elegant moments in the entire factory. With the oil completely ready, we enter the most impressive point of this act, the bottling line, a true mechanical ballet. Imagine dozens of empty bottles being aligned with millimetric precision while robotic arms position them on the conveyor. Then filling nozzles descend in perfect sync, releasing the exact amount of oil into each bottle. There's no waste, no error. It's like watching a perfectly rehearsed industrial choreography. And here is a number that always surprises factory visitors. Some production lines can fill more than 600 bottles per minute. An impressive number. This means that in less than 10 seconds, a single machine produces enough bottles to supply a small neighborhood market. The combination of speed and precision is so absurd that if a sensor detects any flaw, a crooked label, an incorrect volume, a POORLY fitted cap, the bottle is instantly removed from the conveyor by a robotic arm. Nothing goes unnoticed. After filling, the bottles move to the sealers, where caps are placed with calibrated torque. The force must be strong enough to prevent leaks, but never beyond necessary so that consumers can open easily. Then the bottles pass through label applicators that use air jets to fix each label without bubbles or creases. The result is an aesthetically perfect bottle ready to be displayed in a market. But the work doesn't stop there. Before being sent to packaging, all bottles go through an optical inspection stage where high-resolution cameras analyze color transparency and filling. If the oil is slightly out of the color standard, even if it is imperceptible to human eyes, the system identifies and automatically discards it. It's a final barrier that ensures only the very best gets distributed. After inspection, we arrive at packaging, where machines assemble cardboard boxers in seconds and organize bottles in perfect rows. Automatic palletizers stack these boxers into giant blocks ready for transport. Each pallet can carry hundreds of bottles, and in large factories, dozens of these pallets leave every hour heading to distribution centers across the country. It is at this moment that the grandeur of the process becomes evident. From dry hard grains to perfectly sealed bottles, corn oil goes through a journey of brute force chemical delicacy, robotic precision, and almost obsessive quality control. And all of this to ensure that the final product arrives pure, safe, and stable to the consumer. But the story doesn't end here. This oil travels thousands of kilometers, reaches international markets, and has uses that go far beyond your kitchen. Want to know where else corn oil ends up? And how it impacts the global economy? Then make sure you're subscribed to the channel, because we still have a lot more to reveal. Leave your like, share this video with someone who loves discovering how things are made, and tell me in the comments which part of this process surprised you the most. A big hug, and see you in the next episode of Behind the Scenes in Industry.